All right, in this video I'm going to look to finish up section 3.4 and 3.5, or basically finish up chapter 3 altogether here. So all we have left is problem 20. Let's take a look at that. It says the following data represent the test scores on a final exam for 27 students in a statistics class. Okay, so here's our scores there. Now notice that these are out of order. Okay, which is different from the last couple of problems that I did, because I gave you the data values. They were already in order. Okay, so when I find the 5-number summary, the first thing that I would have to do is I would need to order the data set. Okay, or I can use my calculator to compute as the same. Okay, so let's see here in the T84. You're going to hit stat and enter. Okay, you're going to type in all the values. So there's 75, 40, 79, 80, 57, okay, etc. And then I'm going to hit stat, go over to calc, and then one var stats. And now I need the quartiles, or I basically need the 5-number summary here. So the minimum value in the data set is 31, the first quartile is 66, the median, which is the same as the second quartile, is 79, the third quartile is 87, and the max value is 99. Okay. So there's the 5-number summary. In part B, I need to determine the fences, and then answer the question, are there any outliers? So the first thing that I need to find is the interquartile range. Okay, so I take the third quartile minus the first quartile. 87 minus 66 gives me 21 for the interquartile range. And by the way, just a note here, the interquartile range, well, for this problem it doesn't make sense, but for usually it would make sense. So remember the interquartile range represents the middle 50% spread of the data values. Okay, so in a bell-shaped distribution, that would be important to us because you're representing most of the data there in the interquartile range. Find the fences there. The lower fence, I need to take the min value, or excuse me, the first quartile. 66 minus 1.5 times the interquartile range, 21, and so I get 34.5. And then the upper fence, when I take 87, which is the third quartile, plus 1.5 times the interquartile range, I get 118.5. Okay, and remember that these serve as boundaries, and if you're outside of the boundaries, you consider that an outlier. Okay, now there's no scores that are above 118.5. Okay, so there's no outliers on the far right side, but 31 would be an outlier. Okay, so I've got that stated there. The test score of 31 would be an outlier because 31 is less than 34.5. Okay. Part C in this, so they want us to construct a box plot for the data. So remember how we find a box plot is we need to first find the 5-number summary. Okay, and I've done that. I've found the fences, and then now I'm going to draw a horizontal scale to include the 5-number summary. So I need some sort of scale that's going to be big enough to include the numbers 31 through 99. So what I chose to do here was to have a scale that goes in increments of 10, starting at 30 and going to 100. Okay. If you were to choose another scale, going in increments of 5, that'd be fine. And label the axis. Okay, this is statistics final exam scores. Okay. Now above the scale, I need to draw a box from the first quartile to the third quartile. Okay, so the first quartile is 66, the third quartile is 87. and in the middle, in the box, I draw a vertical line at the median. The median is 79. Okay. Now, the next thing I do is I need to draw a horizontal line at the middle of the box from the first quartile to the smallest value that is larger than the lower fence. Okay, so the smallest value that is larger than the lower fence is 34.5. Okay, so if you were to look in the data set, the smallest number that is larger than 34.5 should be 40. Okay, so I draw my left whisker going from 66 to 40, and then I draw my right whisker going from 87 to 99. Okay, it says draw another horizontal line at the middle of the box from the third quartile, 87, to the largest value that is smaller than the upper fence. Okay, well, I didn't. The upper fence was 118.5, so the next smallest number would be the max value, 99. Okay, so I've got my whiskers drawn. Now I'm on the final step here. Any data values less than the lower fence or greater than the upper fence are called outliers and should be marked with an asterisk. Okay, so 31 is an outlier, so I mark 31 with an asterisk. And by the way, it's common to include the 5 numbers into the box plot, along with any outliers and such, just so that you know where you're starting, where you're ending. I'm not using a scale of 1. Okay, so it might be tough to tell. Like, is this 79 or is it 78 or is it what is this number? Okay, so this is more for the reader to build on and make sure that they understand your box plot display and the key 5 number summary there that should be labeled. Okay, and by the way, you can label this on the axis is fine, okay, or on the box plot is fine. Just make sure that the 5 number summaries are there, okay. If you're making this by hand, in other words. Part D, I need to use the box plot to describe the shape of the distribution. Okay, well, the median looks like it's to the right of the center of the box, and the left line looks like it's substantially longer than the right line. Now, if either one of those two things happen, here they both happen, so it's no question about it. But if either one of those things happen, I call the distribution skewed to the left. Okay. Plus, I've got an outlier there on the left side, so this is no doubt skewed to the left. There's no other distribution shape that I'd want to classify this as. Okay. So and by the way, if I were to make a histogram, I would get the same conclusion. Okay. The left tail would be longer than the right tail. Okay, for it to be skewed to the left. Okay, so that's all we're saying there with if it's skewed one way or the other. The homework here in 3.4 and 3.5 is listed. Be sure to look at these problems when you get a chance. And at this point, we're now done with chapter 3, and so we'll start in on chapter 4 next.